Um, and it's been really fun to meet all the other faculty here, to grow with them and make new connections with them. And actually, new faculty keep coming to the university and new students keep joining the university. And so it's a great environment to keep learning. I did my undergraduate work at Brown in cognitive science, which is sort of still one of my main interests. And I actually went to high school in Rhode Island as well. My family moved around a little bit while I was growing up. So I spent a lot of time in Connecticut suburbs of New York City. But around high school, my dad slowed down his career track and we moved to Rhode Island, which is closer to my mom's family. And I was actually a little bit disappointed that I wound up going to college so close to home. But fortunately, my parents didn't make me come home every weekend, or I got the independence that I wanted. I did my PhD at the University of Pennsylvania in Philadelphia, which at the time was one of the best places to do research in natural language technology. As you can imagine, sort of 30 years ago, natural language technology was not a big deal like it is today. So there weren't a lot of universities that had a lot of expertise in it. And Penn at the time had 4 professors in it, which just about nowhere in the world else had. And if you're thinking of going to graduate school, it's always good to go to a place that has, a handful of different professors that you think you might work with, because it means that if you don't get along with one of them, there's always going to be someone else that can be your advisor. Yeah, that's me. Happy to talk more about any of that, but.
So our next question is, what caused you to major in your undergrad in cognitive science and then do your PhD? Further natural language is what I think you said.
Yeah, right. So I was, there are a bunch of things that got me interested in language as a kind of formal system already kind of in high school. Believe it or not, actually, it's probably pretty easy to believe. One of these was J.R.R. Tolkien's Invented Languages. So if you get really into the Lord of the Rings, you discover that all of the Elvish languages are sort of related, and they have the same kind of grammar changes and sound changes in them that also characterize the evolution of real languages. There are really surprising, simple formal rules that describe the sound changes that happen as language evolves and the grammar changes that happen as language evolves. A lot of them can be described with like the finite state machines and regular expressions that you learn in Python programming. So when you see the scientific study of language, it's very much tied to the kind of mechanical kinds of rules that computer scientists study. And I guess I was also particularly interested in some of the aspects of artificial intelligence, particularly probably what I was really interested in was consciousness and like sort of the kind of neuroscience of thought and self, and from reading Douglas Hofstadter's book, Gödel, Escher, Bach. And so cognitive science was kind of a field that let you sort of study these things. I have to say that like part of why I wound up at Brown is that it's sort of famous for having sort of no requirements and letting you do whatever you want as an undergrad. And so I never wanted to take an English class again after high school. And I also, I didn't want to have to take operating systems, and I didn't want to have to take, phonetics. So I got to take the linguistics courses and the CS courses that I wanted and make my own major out of it.
Our next question is, what are some of your favorite memories as a computer science student?
Like at Rutgers?
Yes.
Yeah, okay, sure. Well, I've been like, I've had a bunch of really awesome like honors undergraduates that did like year-long projects with me. And it's particularly with a lot of them, when you do an independent study or a thesis, and it's really your own project and your own topic, then you get to learn a lot, but you also sort of realize that learning is this kind of open-ended process and that you kind of have to keep working on it. So I have probably 4 or 5 students that I could tell similar stories about, but I'm going to tell the story of Laura Martin. Laura Martin graduated from Rutgers maybe, I think 8 years ago or something. She just finished her PhD from Georgia Tech a couple months ago and is now doing a postdoc at Penn. So I'm actually hoping to be able to invite her back to the department once we can invite anyone back to the department. So she picked this really hard, really interesting project for her thesis, which was understanding how uncertainty is reflected in the way that people give spoken responses. So like, basically, how can you tell from someone's voice whether they're confident in what they're saying or unsure of it? And it was a really sort of challenging problem because she had to kind of get recordings. She had to process those recordings with like computer technology to like build a classifier. And then she had to sort of check the results with people to see if the predictions were correct, and also to see if the computer was sensitive to the same features of the speech that people pick up on, let's say. And so she had to spend like most of like a year just designing the experiment. And during this time, like the advice that I gave her, which is advice that I give anyone, is that like when you don't know if something's going to work, do a quick kind of back of the envelope calculation, or write a really small piece of code, or work with a really small piece of data, so that you can quickly see if you're on the right track or on the wrong track. And this is advice that's often given to startup companies, where it's called fail fast. The idea is that like you have to try a lot of things, and if you can't tell early that whether it's working or not, you'll be wasting time. You really need to be able to tell right away if something doesn't work, so you can move on to something else, because nothing works the first time. So, so the difference between sort of the people that succeed and the people that don't succeed is not how often they fail, or maybe it is how often they fail. The people that succeed fail more. At graduation time, Lara presented me with this framed cross stitch that says "fail fast." That's in my office in CBIM now still. Sort of lonely in the pandemic, but again, when you can come uh, to Rutgers, you'll be able to see that.
Our next question is, what led you to Rutgers?
So again, this is another good story. So the academic job market in the late 90s in AI was actually not very good. And again, I know that seems hard to believe now, but this was before Google even existed. So like the internet wasn't a commercial thing at all. And so there wasn't a whole lot of opportunities. And so when I was graduating, I sort of sent out a small number of job applications to the places that seemed open at the time. But really, I was expecting that I would do a postdoc. And actually, I had some really awesome postdocs lined up that would have been really fun, because it wasn't that easy to get an academic job. And the thing that was particularly complicated was that I was also hoping to live at least somewhere close to my partner, who was also finishing up his PhD at the same time and was also looking for an academic job. So at the end, like we did the search, and amazingly, I got 2 faculty positions, one in Edinburgh and one at Rutgers. And he got 2 faculty positions, one in Ohio State and one at Rutgers. And so that was not an accident, by the way. People at Rutgers were pretty excited, sort of worked behind the scenes to make sure that we both could get a job here. And so sort of that was basically an offer that we couldn't refuse. He now works at Google. He was on the faculty here for about 10 years, but then decided that research wasn't working for him. So.
The next question is, what led you to want to teach computational thinking to the PhD students?
Well, so I was really inspired by an article that Jeanette Wing wrote. Jeanette Wing is now the director of the Data Science Institute at Columbia University. But at the time, she was the director at NSF, I think, for computer information science and engineering. And she put this article together advocating that sort of everybody should learn computer science. And she wanted to change the conversation. You know, there's a lot of times when people say everyone should learn computer science, it's like, so everyone can be a programmer, or so that everyone can have a job that has a technical component. And what Jeanette Wing was arguing was that actually we need lawyers that know computer science, and we need doctors that know computer science, and we need, you know, electricians that know computer science, and all kinds of people should know computer science, and because so many of the sort of things that happen in our society are informed by computer science, and being able to just think precisely about algorithms or efficiency or complexity, helps you, informs your everyday life, as much as like algebra would or calculus would, these things that we already do teach to everybody. And that really resonated with me at the graduate level, because I've been working with a lot of students from the philosophy department, or from the linguistics department, or from the psychology department. And these students were super, super smart, and they were actually interested in questions where kind of computer science training would help. But because they'd been an English major or whatever as an undergraduate, they didn't have this kind of technical background. So we got a big grant from the NSF to have interdisciplinary training at Rutgers that could allow more people to include computer science ideas as part of their graduate work. And so the course evolved out of that.
So just a question to clarify. So the computational thinking class you did teach was kind of to give more grad students a chance to incorporate CS topics into their own research?
That's right, or to be able to collaborate with computer scientists. So, I mean, there are a bunch of students that where it really worked out for them. So Gabe Greenberg was a philosophy PhD student, but what he was really interested in was visual communication. So he has actually a dual major as an undergrad of philosophy and art. And so he was super interested in like sort of how maps and diagrams and line drawings worked. And for that, it turns out that it's really helpful to think about the algorithms that are used in rendering and computer graphics, because they provide a really clear model of how an image is formed from a kind of mathematical description of the world. And that's very much the way that philosophers think about like the meanings of imagery or something like that. So he took that class, and actually he liked that class, and now teaches a version of the class at UCLA to philosophy undergrads. And you should check out his work. He has some awesome work on the interpretation of film, how it is that you interpret the changes in shot when you cut from one scene to another in terms of like the underlying geometry of the scene.
That's really cool, because Rutgers is such a big research school. Like the fact that you yourself made this course, like to help all these research students, like possibly incorporate CS into their research if they wanted to, is such a big accomplishment. So this leads to our following question, or sorry, next question. Why did you choose to go into research, and why specifically was one of the topics you chose to research intelligent systems?
So I guess going into research was kind of, I guess I didn't notice when I stopped learning from books and started figuring stuff out for myself. I had some really excellent mentors as an undergrad that really didn't even let me know when I was starting to do research. So my undergraduate honors thesis advisor was Pauline Jacobson, who's a linguistics professor at Brown. And the way that she taught the class was always to present a theory in linguistics, to present the evidence for the theory in terms of the underlying data, which is usually your own intuitive judgments about what a sentence means or whether a sentence is possible or grammatical. And then sort of at the end of every lecture, she'd say, sort of, here's the data that theory doesn't explain, and nobody knows why. Maybe you can figure it out. And so, there were just lots of opportunities to see for yourself whether different versions of the theory might explain the data better, or whether you could, and there's always a lot of options in linguistic theory, because a lot depends always on how you describe the lexical items, the words in the language. And even without changing the big principles of the theory, by giving a slightly different description of the words in the language, you can often get useful changes in the predictions of the theory. So it was sort of very natural to start doing that. And I guess, how should I say this? Like, one thing that I want to recreate at Rutgers, that I took away from my undergraduate experience, is that everyone at Brown was really ambitious for the students. Like, all my faculty members, they would kind of push us in a very nice way to take our work very seriously. Like about halfway through my thesis, I guess, like sort of at the end of the first semester, Brown's also very informal. So Polly told me that I should just send an abstract of my thesis to a conference. And so she helped me write up the abstract and explained what it was that I was working on and what my arguments were, and it got in. So like my experience at research starts with presenting at this conference when I was an undergraduate, my undergrad thesis work. How should I say this? I probably got the impression from that experience that research was easier than it is. And if I had had all of the setbacks that normally accompany the start of research, I'm not sure I would have gone into it so smoothly, but it really seemed like it was for me.
Of all your publications, which one is your favorite?
So probably the one that was the most fun to work on and had the most impact is the paper that I wrote with a team in 2004. That appeared at the SIGGRAPH conference, called Speaking with Hands. And it's was one of the first kind of practical data-driven techniques for animating conversational characters in video games. And that technique is actually kind of, in fact, used in industry today. It was a really fun project because it was a really diverse group of people with all different expertise. And we were able to work together pretty effectively by making mock-ups of the research and dividing the labor and sharing our knowledge. And yeah, so that was something that worked out really well. I'm happy to tell it's like asking which one of your children is your favorite. Like, I'll get myself in trouble if I answer it too partially. So I'm happy to talk about all the other papers.
Our next question is about your keynote. On the Rutgers website for your page, it said you gave a keynote at the 19th Amsterdam Colloquium on coherence and meaning in dialogue. So could you just tell us more about that?
Sure. So this was based on maybe my second favorite paper, which is a paper that I wrote with Una Stojnic. Una was a graduate student at Rutgers in philosophy. She's now a professor at Princeton. And we looked at a video by Weihart. Weihart is a kind of mathematics educator with the Khan Academy at the time, she was doing this video blog where she was explaining mathematical concepts. And she posted this origami proof of the Pythagorean theorem. So what she does is use a piece of paper, and basically by folding that piece of paper 2 different ways, you kind of get a visual explanation of the kind of algebra for why a squared plus b squared has to equal c squared. So it's really precise. It's probably not something that you've thought about before, so it's really creative. And it also kind of crucially puts together what you're seeing on the screen with what she's saying. And so, I talked about my work on animated characters before, and I talked about like Gabe's work on maps and film. A lot of effective communication requires, you can't necessarily put your ideas into words. You might have to show somebody or do something, or somehow get someone to have their own experience that you can then kind of comment on, that sort of gets the idea across. And I guess, looking ahead, that's, if you're going to want to teach a robot, like you're not going to want to have to explain everything in words. You're going to want to have to be able to just show what you want sometimes. Understanding how it is that you can use language and a demonstration together to get an idea across is really hard, but it's really important. And so, but working with math, in some sense, it's easier because we know what the ideas are in math. We actually don't know what the ideas are really behind a robot plan. Like we can't write down a program that a robot could use to tie its shoes. Like we have no idea how to do that. But we do know how to write down the proof of a Pythagorean theorem in a way that a computer can check. Basically, this is this neat bridge between the kind of content that we understand and the ideas that we want to be able to get computers to understand. And it's just really fun. So basically, I talked for an hour about this beautiful video.
The next question is, what are some of your professional goals that you're working on right now?
Thanks. So I'm still working on research, and I guess one of the things that I've been thinking a lot about in collaboration with Amelie Marianne and David Pennock on the faculty here is how interactive computer systems can sort of make better decisions. The computer systems that I write, they always have to kind of maximize an objective. There's sort of, maybe they want to have a successful interaction with the user. Maybe they want to take as little time as possible. Maybe they want to get an outcome with a particular score, whatever. But there's always uncertainty, and the outcomes with different people are going to be different. AI researchers haven't thought enough about what the right way is to make decisions when you're affecting different people and there's uncertainty about what the outcome's going to be. And so Dave suggested a bunch of research in the economics community and the computer science and economics community about algorithms for making decisions that are more fair. The one that he's particularly fond of is something called Nash welfare, where instead of averaging the outcomes that you get across people, you multiply them together. And what that does is it's sort of like in the same way that like the square has the biggest possible area with a given perimeter, you basically, it balances the outcomes for the different people, like their different dimensions that you want to optimize. And so there's a lot of algorithmic questions about how you would implement this in the kind of technology that people currently use for reinforcement learning. There's also a lot of kind of analytical work that you need to do to understand how to interpret that behavior and check that it's intuitively good. And you also need to make sure that it works with people the way that you intend it to do by like running human subjects experiments. And that project is something that Dave and Emily and I are working sort of very hard on to be able to get funding for, to really immerse ourselves in over the next couple of years. So like, research-wise, that's probably the highlight right now. As department chair, there's not that much that I can do, actually. Most of the work is filling out paperwork, and the faculty really do what they want, and the dean gives me as little money as possible. So like a lot of what I'm doing is just being a cheerleader. But in my role as cheerleader, I am really working very hard to increase the diversity of course offerings that we have at the undergraduate level. So instead of just having these, having everybody in the 500-person algorithms class, you're able to take courses as a junior and senior that really get into more specialized areas of computer science. We've already gotten a new kind of data science course on the books this year. We're going to get new machine learning courses on the books next year. And we're also looking at creating kind of new courses in computing and society, like in algorithms in the wild course. Let me know what else I should be asking for, because what we're really trying to do is to be able to serve you better, and also like sort of let the faculty really share the ideas that they're most passionate about. So that's kind of my professional goal in the department.
I just noticed in the chat that Samantha mentioned an ethics course would be really awesome. Ethics and technology.
Well, it's definitely on our radar.
Our next question is, what is something you wish you knew before pursuing your PhD?
So so part of what I wish I had known a little bit more about like the kind of work-life balance that would work for me. There were a couple of years in graduate school like that I didn't do any physical activity. I was like just there by the computer, and that was really unhealthy. So I wish I had taken a yoga class before I started grad school. I also wish I had a little bit more mentorship about what it means that academia is a community. When you are a student, you have all this time, and it seems like the library is just there for you, or Google Scholar is just there for you. You can spend as much time as you want, like looking up papers, and sort of everything's new. And some people would say, like if you write something up about this, send it to me or things like this. But I never did it. And it turns out it's really important because like people really do need those push notifications sometimes. Like it's not enough to just like present your paper at the conference and assume that everybody who cared about it was there in the audience. It's hard to find out about stuff in academia. And it's also, when you take the chance to sort of write a little bit of a personal introduction to a paper, sending it on to somebody, you can sort of treat the paper as part of a longer conversation. And when you're earlier on in your career, like that's how you sort of get exposure for yourself. But in some sense, later on in your career, when you're like me, it's having those papers come in is how you sort of stay on top of things. And so if you haven't put yourself out there earlier, then things don't come back in later, and it just slows you down. So work-life balance and a kind of collaborative mindset.
What should undergraduate students hoping to pursue PhDs be doing in college to prepare for their applications?
So let me just say a couple of things. Like, it's, like if you're lucky enough, to get research experience and research results and, to know exactly what you want to do, then that's great. And but you don't have to. Like Laura Martin, who I mentioned before, who just graduated from Georgia Tech, she wound up not going directly from Rutgers to her PhD. She did 2 years in the master's program in language technologies at Carnegie Mellon. And she learned a ton there. She was actually learned that her interests were slightly different from what she thought as an undergrad. And then the PhD program that she got into was much, much better than any of the PhD programs that she got into as an undergrad. Basically Georgia Tech is top 10. And of course, like CMU is as good as it gets. So, like, it's more important that you learn what you want to study and learn what you're interested in and learn whether you like research than that you get the credentials to get into the top school right away. I mean, plenty of people are able to do both of those things at Rutgers. There's no reason, not to. We're really hoping to provide as many opportunities for students to get involved in research as we can. But, lots of people do that first research project and they hate it. And they realize that they wanted to do something else. And that's fine. That's good. Like, it's, so, but, I don't know what year people are in typically. I'll talk to everybody. As a first year student or a second year student, the most important thing is to plan the coursework that you do so that you're getting into those key gateway upper level classes that really start to teach research techniques as quickly as you can. So sort of like, if you are interested in something like AI or machine learning or data science, if you take those courses, at the start of your junior year, then you can, it means that when you work in someone's research lab over the summer or in your thesis or in the spring of your junior year, you'll be able to get up and running. You'll be able to really finish something. And, sort of for research experiences going to grad school, the thing that really matters is whether you finish something. So like whether the mentor for your research is able to write, remember this is at the time that the applications go in. So in December, that like this person had this idea and they implemented it and they tested it and it worked and the paper is under review. Right? That's kind of the research thing that gets you kind of over the bar. Not everybody needs that, and not everybody needs to go to a PhD program right away. But if you want to think, what gives you the most options in terms of getting into a research program right away, it's that. But a lot has to go right. The most important thing being that like you even like the thing that you do research on, and there's nothing wrong with it if it takes a little
longer. Our next question is, what do you like to do outside of research and work, aka your hobbies?
Yeah, so I mean, I mentioned yoga already. I'm pretty, my practice at home is not what it was when I could actually go to the studio. So I'm really looking forward to getting back to that again after the pandemic. I also try to swim every day that I'm on campus at Rutgers. The Warblin pool might very well be my favorite thing about Rutgers. Of course, it's the students. I mean, but it's really special that I can just walk 5 minutes and be at one of the best pools on the East Coast. Something else about me. A couple of years ago, Doug and I bought a house in Northwest New Jersey, which is where I am now during the pandemic, which is on 9 acres of land. And we have a forest stewardship plan, which requires us to restore the land. This was pasture land until probably the 1930s. And then the property was kind of gradually let to run wild. And it turns out if you let property run wild, it's not like a normal forest that grows back. It's sort of glorified weeds. And what we have right now is a whole bunch of cedar trees, which grow on open fields, but which are crowding out the oak trees and maple trees and walnut trees and birch trees that would normally be growing in on this property. So basically, when the weather is good, I go out for about an hour a day in the afternoon now and chop down cedar trees with a chainsaw.
Just one question I had about your research. On your website, some of the topics it said you research were like natural language generation, computational semantics, conversational agents, etc. It seems like a lot of the research you did was kind of focused on linguistics and conversational things in CS and I guess in person as well. So my question is, do you think like after all this research, has this changed the way you communicate or think about communication?
In some ways, yes, for sure. In some ways, no. So people actually have really good intuitions about meaning. And people are, of course, really successful at getting their ideas across to one another. And they're even often quite good at sort of recognizing and repairing sources of miscommunication or sources of uncertainty. so like in many, basically in many ways, a lot of what's hard about AI is figuring out how it is that people do the stuff that we obviously do. And the same is true for vision or movement or learning. I would say, though, that studying language for a long time has definitely changed what I think is important about the processes that underlie communication. So one example of this, which is actually something that Una Stoyanich and I are going to be talking about at a conference in Princeton in May, which is going to be like sort of free and open to the public, so you can keep a lookout for the announcement for that. The conference is on the common ground, and so it's a well-known sort of principle of anytime multiple agents act together, they need to have shared information to do it. And the easiest example of this is just like, what side of the road do you drive on? Do you drive on the right, like in the US, or do you drive on the left, like in England? You can do whatever you want. You just want to do the same thing that everybody else does. People characterize that in terms of shared knowledge or mutual knowledge. And a lot of research in philosophy and a lot of early research in AI characterized this kind of shared knowledge in terms of logic. And so like one of the main things that I worked on in my thesis was some new algorithms for reasoning about this kind of common ground. Well, it turns out that just the idea that you reason about the common ground is maybe a little bit misleading for what happens in the conversation. Another way to think about it is that you create the common ground by the actions and responses that you make with the person that you're talking to. So the question is like maintaining the common ground more like reading a book, or is it more like dancing a dance? And work in AI that emphasizes the importance of machine learning, that emphasizes the importance of kind of embodiment and interaction. These things have led me to think that the common ground is more like a dance than like reading a book. So it's something that we're doing together. And so that's one of the reasons why I build a lot of computer systems to test my ideas and see how they work with real people, because what you really want to do is create this feedback loop where you're getting good outcomes and avoiding problematic situations. And that's more important than, in some sense, having the right information in the system.
So someone asked in the chat that they would like to hear more about your publications. I know it's hard for you to pick a favorite, but is there another one you'd like to highlight?
So actually, I really like the paper that I just spent, the most recent paper, which probably isn't on my website yet, but probably you can get on the ACL anthology at Coling 2020, which is a paper about using reinforcement learning to ask better clarification questions. And one of the things that I liked about this paper that made it fun to work on was that we sort of discovered something interesting about people by working on this project. You can ask clarification questions in a bad way, and people will think that you're just being pedantic or that you're correcting them and not that you're genuinely confused. And so people will when people think that, they always answer yes to your clarification questions, even if the answer is no. It's like, like one of our things said, do you mean beige? And people always answer yes to that, regardless of whether that's whether what the computer means is anything like what they meant. So what reinforcement learning allows you to do is kind of measure that. But the fact that you can do it wrong and that people will answer in these surprising ways is why it's important to run these experiments and have machine learning in the system. So I really, that shaped my thinking a lot. Another recent paper that's sort of totally different, but that also I spent a lot of time on and really enjoyed, is a paper about the phenomenon of malapropisms, which is when you when someone uses a word with a misunderstanding about what it means. A silly one is sort of a pretentious person in a position of authority who tells to a bystander, I jeopardize you to fulfill my duties, instead of I deputize you. And usually you understand what the person means a lot of times. And the question is sort of like, how should you think about that? And there's a bunch of philosophical views about it that I explore with Ernie Lepore in the philosophy department in this paper. Before concluding that people are sort of in something like that person was actually had in mind the word deputize and pronounced it wrong, rather than having in mind the word jeopardize and not knowing what it means. So it's sort of like there's some, philosophers are good at sort of teasing apart these kinds of common sense ideas. But it turns out to matter a lot. We do a lot of data-driven study of color descriptions of color patches. And one of the words that we've looked at is the word vermilion, which is a specific orange-red dye that's actually made from mercury. It's really toxic, but it was one of the few bright color-safe dyes that people had in the Middle Ages, so it was very valuable. But it's a kind of obscure long word, so not everybody sort of interprets it the same way. And if you look at our corpus, lots of people that just assume that it means bright green because it sounds like vermilion. It sounds like it could easily mean bright green. That must be what it is. So sort of whenever you're building these language understanding systems, you always have to be prepared for sort of weird stuff. And you need to have a whole range of kinds of hypotheses and strategies to be able to deal with the unexpected things that people do.
So with that, we'd like to conclude this event. Thank you for answering all our questions, Professor Stone, and thank you for taking the time to talk to us. And thanks to all of our members for joining in today.
Thanks everybody for having me. Please enjoy the computer science department and don't feel shy about giving me feedback about what we're doing well and what we need to improve. And especially, sort of, if there are things that you want to see us do, we are totally open to good suggestions.
Thanks, everyone. Good night.
Thank you again.
Thank you.